On the morning of April 27, 1978, 51 construction workers were 166 feet up, building a massive cooling tower in West Virginia, standing on a scaffolding system bolted directly into concrete that had been poured barely 20 hours earlier. Without warning, that concrete gave way. The entire platform and everyone on it fell straight down into the hollow center of the tower. It remains the deadliest construction accident in United States history. In 1978, the Allegheny Power System was expanding the Pleasance Power Station at Willow Island, West Virginia, along the Ohio River. Part of that expansion involved building a second massive cooling tower, a hyperbolic concrete structure over 400 feet tall, used to cool water from the plant's generating process. Building a structure this tall out of concrete requires a specific construction method called climbing formwork. Rather than building scaffolding from the ground up all at once, workers pour a section or lift of concrete, typically about 5 feet tall, let it cure, then unbolt the formwork and scaffolding from that section and rebolt it higher up onto the section just poured, climbing the tower one lift at a time as it rises. This meant the entire working platform, at any given moment, was resting on concrete that had been poured only recently, and its safety depended entirely on that concrete having gained enough strength, quickly enough, to bear the full weight of the workers, the scaffolding, and the cranes hoisting fresh concrete up to them. Here's where the process broke down. The construction plan called for concrete to cure for a set period, commonly cited as around 18 hours before the scaffolding above it was loaded with the next round of work. On the morning of the collapse, the concrete supporting the working platform was reportedly only around 20 hours old. That number alone might not sound alarming, but investigators found several compounding factors. The concrete had been poured the previous day in near-freezing temperatures, which significantly slows the chemical curing process concrete depends on to gain strength, meaning 20 hours in cold weather may have provided meaningfully less actual strength than 20 hours in a warmer climate. Investigators from the National Bureau of Standards also later concluded the broader underlying issue was that the original design simply hadn't adequately accounted for the full range of forces the partially built structure would experience during construction itself, including the dynamic, sudden forces created by cranes hoisting and swinging heavy loads of wet concrete into place. On top of this, an OSHA investigation later found some of the bolts securing the scaffolding to the concrete were undersized for the load, and that formal field testing of the concrete's actual strength, the simple, standard practice of testing a sample to confirm it was ready to bear load, had not been performed before the platform was loaded that morning. On the morning of April 27, 1978, workers were hoisting the third bucket of fresh concrete up to the working platform 166 feet above the ground. Witnesses on the ground reported hearing a loud crack near one of the crane positions. The concrete lift supporting that section of scaffolding gave way. Because the entire scaffolding system was interconnected, bolted together as a single continuous ring around the tower's circumference, the failure didn't stay contained to one section. It spread rapidly around the platform, tearing loose from the tower wall as it went. The entire structure, along with everyone working on it, fell straight down into the hollow interior of the tower. All 51 workers on the platform at the time were killed. It remains, to this day, the deadliest construction accident in the history of the United States. 2 separate investigations followed, one by OSHA, focused on safety violations, and one by West Virginia's governor, focused on broader industry and oversight failures. Together, they identified a combination of factors rather than one single cause. Concrete that likely hadn't reached adequate strength before being loaded, cold weather that would have slowed curing further, undersized bolts or missing bolts in the scaffolding connections, and a design process that hadn't fully modeled the real construction phase loads the structure would face. OSHA's investigation specifically cited the construction company for a knowing and intentional violation, a legal finding that the company was aware standard concrete strength testing wasn't being performed, yet continued the work regardless. The Governor's Commission went further, pointing to a broader absence of adequate worker training, technical supervision, and safety culture on the site as a whole. It's a sobering contrast to some of the design flaw stories elsewhere in this series. This wasn't primarily a flaw baked into blueprints years in advance. It was a breakdown in the basic, ordinary discipline of construction site quality control on a single morning that cost 51 people their lives. Construction on the second cooling tower eventually resumed and was completed. Both towers remain part of the Pleasance Power Station today. The disaster led to increased scrutiny of climbing formwork construction methods industry-wide, more rigorous concrete strength testing requirements before load-bearing work proceeds, and greater attention to how construction phase loads, not just a structure's finished, in-service loads, need to be properly engineered for from the start. Willow Island is still cited today in construction safety training as a stark reminder that a building under construction is, in a real sense, a different structure than the one it will become, one that needs its own careful engineering and its own patience before the next stage of work begins.